Hello everyone, today we're going to look at solving exponential equations. There are two main types and it depends on how many exponents you actually have in the equation. So we're going to start with type 1, just one exponent. They're the ones that are typically easier to solve. The goal is to get the exponential, the b to the x by itself, and have a constant on the other side, so y equals b to the x, so that we can change it to a log form and solve for the exponent. So in our first example, 5 to the x equals 2. It's already in that form, so all we have to do is change it to a logarithm. And that gives us that x equals log base 5 of 2. Now, technically I could leave this as my answer. It's the exact answer, but it's not very helpful to us. I can't really check it. So we're going to plug this into our calculator. But the question is how? So we're going to use what's called a change of base formula. So if I have some logarithm, log base b of a, I can change it to any base that I want. So in particular, I'm going to change it to base c. And I do that by taking the log of my new base, of my original input, So I have the a is on top, and then I'm going to divide by log base, again, c, of my original base. So I'm going to take log base c of a divided by log base c of b. And if I look at the original log, remember the base is a subscript, so it's actually below the a, and that's helpful to remember that it's going to be the log base c of a divided by log base c of b. So what I'm going to do is I'm going to choose a base that I have in my calculator. And our calculators are going to have base 10 and base e. So what we need to do is remember how to use those bases. So log base 10 of x is just log of x. So if there's no base written, it's understood to be base 10. And you should have that in your calculator. And also log base e of x is ln of x, which is the natural log. So if you remember, e is the natural number, so log base e, ln, is the natural log. And again, this is something you should have in your calculator. So if you have a 10 to the power or an e to the power button, then log and ln should be that same button, but possibly the shift or the second. So if you have your calculator handy, I suggest that you take it out and find your log and your ln buttons. So if I want log base 5 of 2, I'm going to use the formula. I'm going to take either the natural log of 5 over the natural log of 2, or log of 5 over log of 2. When you're using your calculator, make sure you're using the parentheses. You don't want to do log of 5 divided by log of 2. So make sure you're closing this parenthesis in particular. And if you do it, you should be getting 0.43 and then a whole bunch of other numbers. Right? Always make sure you check your answer. Does that make sense? Right? I plug in 5 to the power of 0.43 in my calculator, and because I rounded, I'm not getting exactly 2, but I am getting 1.9978, blah, blah, blah. So it's really, really close to 2. So always make sure you check your answer. So let's try another one. 3 times 4 to the 2x equals 10. So my goal here is to isolate my exponent, so I need to get rid of that 3. And I do that by dividing both sides by 3. So 4 to the 2x equals 10 divided by 3. Now this is in an exponential form, and I can change it to a logarithmic form. And that's going to give me 2x equals log base 4 of 10/3. I'm going to plug my log into the change of base formula. This time I'm going to do ln. So ln of 10/3 divided by ln of 4. And that's going to give me 0.8685. that was, remember, 2x. So to get x, divide both sides by 2, and you get 0.434. So notice in the middle of my problem, I did 4 decimals, but at the end I did 3. So I'm going to do 3 decimals for all my final answers, but if I'm ever in the middle of a problem, you always need to do more decimals. So I'm going to do at least 4 if I'm in the middle, and then round to 3 at the end. So let's try another one. 3 to the x squared minus 2 equals 17. The exponent is already isolated, so I'm going to change it to a log. Whoops. And I get that my exponent, x squared minus 2, equals log base 3 of 17. Again, I'm going to use the change of base formula. This time I'm using log base 10. So I have log of 17 divided by log of 3. Get 2.5789. Again, I'm in the middle of the problem. I'm going to use 4 decimals. So that is x squared minus 2. So I'm going to add 2 to both sides. And then to undo the square, remember that's the square root, but also remember that if I'm taking the square root of both sides, I have to remember that it can be positive or negative. So x is plus or minus the square root of this guy. So I get plus or minus 2.140. So I have 2 answers in this case, both perfectly fine. And don't forget, you can also always check your answer. Plug it back in and make sure that you get out 17. It's always really, really important that you check your answers. Okay, so type 2 is when we have 2 exponents. The first thing you want to check when you have 2 exponents is to see if you can change your bases into the same base. If you can, then the problem is going to be super, super easy compared to kind of difficult if you can't do it. So for our first example, we have 4 to the x plus 3 equals 8 to the 2x. So I look at my bases 4 and 8 and say, can I write them as the same base? And hopefully we realize that 4 and 8 are both powers of 2. So I'm going to change my 4 into 2 squared and change my 8 into 2 cubed. So I want to make it so that they're both powers of 2. Now I'm going to use the rules of exponents that say if I have something to a power, then I multiply those powers. So 2 to the 2 to the x plus 3 becomes 2 to the 2x plus 6, and 2 cubed to the 2x becomes 2 to the 6x. Okay. Now here we can kind of think of the 2's, the base 2's, as canceling. I'm not dividing by 2, I'm not subtracting 2. Okay, I'm not doing an operation, I'm just kind of mentally canceling the 2's. And I have that 2x plus 6 equals 6 to the x. If I have 2 to a power, or really anything to a power, and it equals 2 to another power, those powers have to be equal. It's the only way that's going to work. Okay, so I can, again, mentally cancel the 2's, the bases, and be left with my exponent equals my exponent. Then at this stage, it's a really nice, simple linear equation, and I just need to get x by itself. And hopefully you can see that x is going to be 3/2. Okay, and again, you can always check it, right? Plug it back into both of them, make sure you get the same thing. So let's try another one. 3 to the 4x plus 1 equals 27 to the x minus 1. I look at my bases 3 and 27, and notice that 27 is a power of 3. So I'm going to change 27 into 3 cubed. Again, I'm going to use rules of exponents. And 3 cubed to the x minus 1 becomes 3 to the 3x minus 3. And again, I have 3 to a power equals 3 to a power. So my powers are going to cancel, and I'm just, my base is going to cancel, and I'm left with my exponents equal my exponent. So 4x plus 1 equals 3x minus 3. Again, you want to put all your x's on one side, all your constants on the other, solve this for x. And hopefully you can see that x equals negative 4. Okay, so let's try another one. A 3 to the 4x equals 4 to the x minus 2. So here, 3 and 4 are not powers of the same number. I can't write 4 as 3 to a power, and 3 is prime, so I can't write that as anything else to a power. So I can't change them into the same base. So that's going to give us two choices. The first choice is that I'm going to choose one side to be my exponent. So one of those sides is going to be my b to the x. The other side is just going to be my y, so the other side. And then I'm going to change it to a logarithmic form. So in this case, I'm choosing 4 to the x minus 2 as my exponential, and the 3 to the 4x as my y. So my exponent, x minus 2, equals log base 4 of the other side, so of 3 to the 4x. Okay. The next thing I'm going to do is I'm going to use the rules of logs, and I'm going to bring my exponent, that 4x, down as a coefficient. So I have x minus 2 equals 4x times log base 4 of 3. The next thing I do is use my change of base formula. So log base 4 of 3 is going to become ln of 3 over ln of 4, or log of 3 over log of 4. Again, it doesn't matter which one. But I'm also putting my coefficients together. So 4 times ln of 3 over ln of 4 times x. I'm going to plug that into my calculator. Again, I'm in the middle of a problem, so I'm going to do that to 4 decimals, and I get 3.1699. Now again, it's a linear equation. Put everything with an x on one side. So I'm going to subtract my x from both sides, and then divide by my coefficient. So I get x equals negative 0.922. Again, you should check it. Check first on your calculator that you're getting the same things, and also check it back into the original problem and make sure your answer is correct. Okay, so that's the first choice. Make one side your exponential, make one side your y. On the next example, we're going to see the other choice. So 2 to the 3x equals 5 to the x minus 1. Again, 2 and 5 are not powers of the same base, so I can't rewrite it using the same base. So the second choice is to take the log of any base of both sides. So in the base you want to choose has to be something in your calculator. So you're going to either choose log base 10 or ln. So in this case I'm using ln. So 2 to the 3x equals 5 to the x minus 1 becomes ln of 2 to the 3x equals ln of 5 to the x minus 1. And then, just like before, I'm going to use the rules of logs to bring down my exponents as coefficients. So notice that in the right-hand one, x minus 5 is a binomial, so make sure you're putting it in parentheses because the entire thing is getting multiplied by ln of 5. Next, I'm going to plug those numbers into my calculator. So on the left, I'm going to do 3 times ln of 2, and that's going to be my 2.079. And then on the left, I'm going to find ln of 5 and then distribute it. So ln of 5 is 1.6094, again 4 decimals, and then I'm distributing it to the x and the minus 1. Okay, and again, what I'm left with is a linear equation. I've got a bunch of decimals in there, so just be really careful about combining your like terms. So I'm going to bring the x over from the right to the left, and I'm left with 0.47x equals the negative 1.6094. Divide by 0.47, and we're getting x equals negative 3.424. Again, my final answer, I'm rounding to 3 decimals. In the middle, it's always at least one more. Okay, and again, you can go back and check your answer, which I highly suggest that you do. So let's try another one. 3 to the 2x equals 6 to the 2 minus x. So 6 is a multiple of 3, but it's not a power of 3. So I can't do what I did before. So in this case, I'm going to consider my 6 to the 2 minus x as my exponential, my 3 to the 2x as my y, so that I have my exponent, 2 minus x, equals log base 6 of the other side, 3 to the 2x. Again, I'll bring the exponent down up front as a coefficient. And then I'm going to find 2 times the log base 6 of 3 in my calculator by doing the change of base formula. So I'd have 2 ln of 3 over ln of 6. And that's going to give me 1.2263. Bring all my x's to one side, so I'm going to add my x to both sides, divide by my coefficient, and I get x equals 0.898. Okay. And then as my last example, I have 4 to the x equals 6 to the x minus 1. Again, I can't write 4 and 6 as a power of the same base, so I'm going to use my choice number 2, and I'm going to take the log of both sides. So again, in this case, I'm going to take the ln of both sides, and then again, I'm going to use rules of exponents, bring down my exponents as coefficients. Again, x minus 1 needs to go in parentheses. I'm going to have to distribute the ln of 6. Next, I will plug in ln of 4 and ln of 6 into my calculator. So ln of 4 is 1.3863, ln of 6, 1.7918, and again, I'm going to distribute it to the x and to the 1. And then I will combine all my x's, so I'll bring my x's to the left, leave my constant on the right, divide by it, and get that x equals 4.419. Okay. So make sure you read through this section on the exponentials, try out the homework, and let me know if you have any questions. Thanks.